Every morning.
So this one is asking us to rationalize our denominator. Now, when we go to rationalize our denominator, my suggestion to you guys as we do this is to right away simplify anything that you can. And the reason why I say that is because when you multiply stuff out later on, it's just sometimes works a little bit easier. Smaller numbers to multiply. So here I've got the square root of 27. That's a 9 and a 3. So I take out the 3 and I leave a 3 in. So I have 3 root 3 minus root 5 over root 15 minus 3. From there, I'm going to multiply by its conjugate. The conjugate of root 15 minus 3 will be root 15 plus 3. Now this one isn't going to be so bad because there's no constant in front of the radical. So this right away is your basic difference of squares, which means it's going to equal a squared minus b squared. Okay? So square root of 15 squared is 15. 3 squared is 9. So I get in the denominator now 15 minus 9, otherwise known as 6. Yes! Error 5. The denominator or the whole thing?
It might have been the numerator.
Okay. So now I do the same thing with the numerator, and I have to FOIL out. So what I'm going to do is I'm going to write the FOIL out down here where I have a little bit more space. So I have a 3 root 3 times a root 15. And then I have plus a 9 root 3. Then I have minus a root 5 times a root 15. And then I have minus a 3 root 5. Now, bear in mind, this is still all over 6, and I'm going to rewrite that here in a minute. I'm going to try and simplify what I can as I go through. Now, if you get lucky like we have here, you're going to start to see that you have a 3, this is a 3 times 15 underneath the radical, which is 3 times 3 times 5. Which means this is the square root of 9 times 5, which means what can I take out? Which becomes a, on the outside. So this now becomes a 9 root 5. This one I can't simplify, so it's still a 9 root 3. And I do the same thing here, minus 5, 5, and a 3. Remember that trick yesterday I showed you guys by putting things in terms of primes? It's kind of the same idea. I'm looking for those prime factors. I have a pair of 5s, which means I can take one of them out. So now I can simplify this a little bit further. I have 9 root 5 minus 3 root 5, 6 root 5. 9 root 3 minus 5 root 3, 4 root 3. And it was all over 6, correct? Am I done? What do I have to do? Yeah, I have a GCF. See how all 3 of the constants are divisible by 2? You can factor out a 2. So your final answer here should be, if we cross our fingers and the machine decides that it's nice to us, and it says, well done. Miss Lori.
If you're going to take a GCF, you have to take it out of every single constant, or else you can't take it out of all.
Correct. It's the same. You simplify this. Remember when we simplified the quadratic formula? Remember we had like 2 plus or minus 4 root 3 all over 2? We could simplify it that way. It's the same basic idea, but we're writing it, instead of having plus minus with radicals, it can be one god-awful looking fraction. That's all. Okay.
But I found some problem, one of the problems. And it says, I got the right, whoa, I pressed the right one.
Oh, wait, I have
Okay, right here. Here we go. I got the right answer, but I can just guess. suggested check.
Oh, these are fun. Oh, I'm sorry, I thought I got you.
Because when I had before, it had like the same kind of numbers, and I was like, hey, probably like the same thing. And I just,
Okay,
yeah, that's yeah.
there you go.
Thank you.
You're welcome. So now I have, what I want you guys to think of here is that we have a whole bunch of junk that needs to be raised to the 1/3 power. Which means I'm going to distribute the exponent to both parts of the monomial within the parentheses. So I have to take, excuse me, negative 27 to the 1/3 times x to the negative 15th also to the 1/3. When you are multiplying exponents, or I'm sorry, get out of the way. When you raise exponents to another exponents, what are you doing to them? You're multiplying them. Thank you for paying attention. So what is negative 15 times 1/3? You get negative 5. So is everybody okay if I just erase this real quick and write it as x to the negative 5? Okay. Now, 1/3 power means cube root. What's the cube root of negative 27? Negative 3. Very good. So now I get negative 3 x to the negative 5th. One of those is not happy. Which one? The negative 5. Where do I send it? Up, down, left, right, start, stop, select? I think it's contra. Akari Warriors was ABBA over and over again. And I'm done. Yes, ma'am.
Okay, I'm not sure if this is meaning negative 1/3 or negative 1 divided by 2. But it'd be the same thing, right?
It would be the same thing, yeah. You even walk that like far over?
No, I didn't mean to make you walk.
I'm trying to avoid Daniel as much as I possibly can. Anna, do you have a question?
We'll do left.
What do you got, Anna?
This one, I wrote it down because I wasn't sure if they were going to stay number 3.
I think so.
Oh yeah, this is a good one. I like this one.
That one made no sense.
Okay.
whatsoever.
Oh.
Sorry for my bad handwriting.
It's okay.
Okay.
What?
I think everybody probably had something similar to this last night,
Oh,
where you had to simplify an nth root that had different nth roots. So here's the deal. When you're simplifying nth roots or fractional exponents, if they start the problem as an nth root and they ask you to simplify, what do you think you should finish in? Nth root. Which one is easier to work with though? Fractions. So here's what we do. I take our nth root problem and I'm going to rewrite them as fractional exponents because it's easier to play the game of war with fractions than it is with nth roots. So I rewrite this as y to the 4/5, and I rewrite the bottom one as y to the 4/6. Excuse me. I have a fake tooth and it's hard to it. 4/6 is what? 2/3. Yes, mas macho. Cuatro fifthos or dos tresos.
I don't correcto. I've never heard
That was a Saturday Night Live skit from back in the way early 80s. It was Ricardo Monfo. Quieres más macho. Anyway, yes ma'am.
Okay, I have another one.
You sound like Buzz Lightyear.
I'm not done yet.
But like after this one, I'm saying.
Yeah, geez, Jaden, I'm waiting for yours to be done.
Which one's bigger, 4/5 or 2/3? 4/5. So what we do is we play the game of war. I know that I have to subtract 2/3 here to make this work. You need the common denominator. Common between a 5 and a 3 is 15. So I get y to the 15. This would be 12/15 minus the other one would be 10/15. My answer is 2/15. So your answer is the 15th root of y squared.
That is how easy it was.
Well, I wouldn't say that it's easy, but the process is whenever you're dealing with nth roots are fine, but it's so much easier to do all the work as a fraction.
That makes so much more sense. I was
Good.
so stuck last night.
Well, now you're not. You can get up and walk around. So the idea is, and the instructions I put on the quiz here is, if it starts as an nth root, put it back as an nth root. If it starts as a fraction, leave it as a fraction. But never leave an nth root or a fraction root in a denominator, which means you rationalize all the time. And I didn't put this in instructions. But I will remind you, assume everything is positive, which means you don't have to worry about what's. Or if you're playing Aussie football, a try. That's what it's called, right?
Or it's a field goal.
I don't know.
Regular football.
That's the rugby. That's what it's called. Yes, ma'am. You could if it was 3/15. Okay, then you can write it out more. What else we got? Or do you want me to show you the other ones I have? We got
What
Jason.
ones you have?
It was like, I don't understand how I got this. It was like, it was another fraction, and it was like,
Do you have it in front of you?
yeah.
How about I write it down? Well, that way I don't feel bad. I want to hit you in the head. I keep lifting over it. I'm going to knock you in the noggin.
I don't know why I got like, why the answer is the way it is. Like, the way I think I was supposed to solve it, like, wasn't the way it, like, got.
I don't think this one's telling you. It says do not rationalize the denominator. So if you didn't, that means you didn't have to take the extra step.
Okay, so I was just really confused. I was like, why?
Yeah. Her question was to simplify this, and then it said do not rationalize. Me, I'm going to say rationalize. Because I'm a rational person.
Oh, really?
No
math.
No math teacher is rational.
So this is 3 to the 1/14 over 7 to the 1, or 3 to the 7. ¿Quieres más macho? Yes, ma'am. Probably not yours. Yes, ma'am. Yeah, but these do too much.
Like, what?
We don't know how to use those ones. Yeah. We don't even know.
So what one wins? 1/7 or 1/14? I haven't figured it out. I haven't decided yet. So this becomes a 2/14. So you get 1. Hey, look, it's pi.
Oh my God.
And then their answer then was that 1 over the 14th root of 3. Now, if I asked you to rationalize this, what would you multiply the top and bottom by? What gets you to a whole? 13/14. In order for me to get to a whole here, you're using your exponent rules. You're trying to figure out how much more 14ths do you have to add together to get to a whole. Well, I'd have to add 13 more. So then if it says rationalize, which it would, your final answer would have been 3 to the 13/14 over 3, but yet it said, hey, nth root. So your nth root would have been 14th root 3 to the 13th over 3. God, that's ugly.
Well, it's not the right answer.
Well, I just said that.
That doesn't make any sense. I'm confused.
Well, I just said if it asked you to rationalize. This one did not. What's that? Basically, this way. Rationalizing your answers always gets rid of all imaginary and radicals and denominators. That's it. Or fractionalized ones.
Okay.
Yes, ma'am.
Where did you get 1 over 3? Why is it 1?
Here we played the game of war. So who won? 2/14 is bigger than 1.
Yeah.
So that's what. If you go back and think of it, if it was this was x over x to the 4th, who wins? So this would become 1 over x to the 4 minus 1. That's what I did. I just did it with fractions. It just looks a lot worse. Okay? All right, let me give you the sheet that I have. It's kind of cool. Yes. It's a great cheat sheet because all the answers are on it. Say Merry Christmas. It seems like he just doesn't. Huh? Who's yelling at me?
I don't spend any money. My parents are the ones who pay. I don't want to spend
Anytime you have
There's just no, it wasn't passing up because you know.
But again, I do realize like
I just asked you so bit sick about this.
It's so happy that you like that's all. Now,
No, it's just not counting. I think that this is
yes, it's a great idea. That's why it's rationalized. So what I want, do you guys need a spare or do I have enough?
we have like 10 spares.
Like if you haven't figured out, counting is not my strong suit.
oh, these are the answers.
Yeah, answers on the back. Isn't that convenient? So you can,
Thank you.
I'm sorry I didn't write on here. Every time you flip over, it doesn't say "well done." So if you want, I can walk around and say "well done" or "try again." So you can just look at either one depending upon what you need it to be. So or you can write it yourself and just laugh
And talk to yourself.
Yes.
You should get like one of those things where like,
I really like math Excel because it's the only time that something else.
What I want to do is I want to jump ahead and look at 29.
you actually really
Yeah.
It's probably the best one.
Why is it only 0?
Oh, you're angry. Oh.
Oh, yeah.
Okay.
Oh, yeah.
So.
What the heck is
Okay. Exponent rules. This is what we do.
what the
Rational exponent rules. So, as you start with these types of problems, yes, they look a lot nastier than they probably really are. Because you've got multiple parts raised to exponents and multiple things to worry about. A couple of things that you would do right away is notice you've got a couple of exponents raised to exponents. But what is the outermost exponent? -1. That means that everything inside the parentheses is unhappy. So the very first thing I would do is rewrite the fraction as flipped.
You didn't give us enough space for this.
Get a different piece of paper.
dang?
And why did I not write down n to the 0? Because it's 1. Okay? Now look at it closely. I have m to the -2 in the numerator and m to the -2 in the denominator. What happens? They cancel out. They become a pair of 1. So what I'm going to do now, also before I even get any further, is rewrite this, just erase it as an n. And is the stuff in the denominator wearing a flotation device? Is it wearing water wings? Does it have a life jacket on?
Yes.
I don't know.
No!
I don't know what that means.
Does it float up to the numerator? What's in the numerator now?
One.
What are you trying to
You'd be surprised at how many times people throw them a life preserver and make the denominator float up when the numerator becomes 1. Guys, make sure you keep him underwater. It's Nemo. He wants to stay there. If Nemo goes out of water, he's dead, becomes a fish stick. Notice I didn't say fish.
For like a minute and
Didn't
then
I?
he got saved.
Well, if he's well, whatever.
Dark
So now I take it the next step. The next step tells me that I have some junk inside here. I have some junk inside the parentheses raised to the second power, which means I have to power and multiply it in. So I'll do that. I have 1 over n. Now I have n squared, and then I have m to the 3/2 squared.
Oh.
I'm using my power to power rule. I'm distributing the exponent to both parts within the parentheses, to both parts of the monomial, if you will. What's 3/2 times 2? 3. You're done. No negative exponents and no fractional exponents. Yeah. It's step by step using the rule, what do you want to call it? I want to say pen pass, what is that called? Word of operations, really by working on the outermost exponent work way in. Yes, sir. What is anything raised to the 0 power? Right. Guys, I cannot hear. What's that? Yeah, remember, originally it was here. It was up here. It would distribute to both parts. This one was on the outside.
No, not that one.
This one?
Yeah.
I swear it. I did it here.
Oh, okay. I didn't see that. Okay. Okay, makes sense. Oh, I wrote it down.
Look at 30. Same basic idea. Yes, ma'am.
Why does it have b to the 0 power in parentheses and then 0 power?
What does it equal? Okay, there you go. Because I tried to scare you with the boo.
See?
I try. I try.
That was actually clever.
Maybe you tried to.
That one was actually.
So you're right. This was here to annoy you. Did that work better? So this, obviously we know that becomes 1. We don't worry about it. Okay? Now I have another chunk that's unhappy. Since this chunk is unhappy, I'm going to raise it up top and rewrite it with a positive exponent. But I'm only worried about this outer exponent. I'm not changing this one yet. We're working our way on the outside in, so you have to take care of this one first before you get to this one. So rewrite it, you're going to get a b to the half times the quantity a to the 3/2, and then b to the negative 3/2 raised to the positive 1/2 now. Okay? Which now means that the junk in parentheses has a power rule to them. Power to power, what do? Multiply. Power to power, we multiply. So what's 3/2 times a half? Three-fourths. And the next one becomes negative 3/4. Okay? That last b is now unhappy. So I'm going to recombine. Is everybody okay if I rewrite that first value of A as a 4/4?
Yeah.
Yeah.
And why am I doing that?
The other one's the name.
And the other one was like 3/7. What would I write it as? Yeah,
Can we just
that's right.
rewrite B as like
So now I have 4/4 and 3/4 become 7/4. B to the half over B to the negative 3/4. Oh, sorry, it's positive. My bad. And you're back to the idea of having to play war. You didn't rationalize. You're back to playing war. What's bigger? 3/4 or a half? So if I take 3/4 and I subtract a half, what am I left with? 1/4. Good. So now you have A 7/4 over B to the 1/4. I am not allowed to have fractional exponents in a denominator. I need to multiply by something to rationalize it. I need to make it whole again.
Oh.
What does it need?
3.
It needs 3/4. The top and bottom need a B to the 3/4, which therefore gives me a denominator of B and a numerator of 7/4 and 3/4. That's kind of the trick here. You get into the fractions, it's so much easier to work with any of these within fractions. What's up?
Would you have to play war again? Where'd the A go? Wait.
I just rewrote it. The A was already there. I just rewrote it to bring it down to rewrite it to my final answer. That's all. Yes, ma'am.
Don't you have to like put the fractions back into radicals?
Did the problem start with radicals?
Oh no, you're right.
If it did, then yes, I would. But in this case, it didn't, so I don't worry about it. Okay. Yes, ma'am.
For number 2, how do you solve it because there's like a 7 group in there?
Ah, I'm glad you asked. Number 2, the 7th
Wait,
group.
why do you end there and why don't you do war again?
If I play war again, I wind up in a battle and I wind up back here.
Okay, so it's just
And then I would wind up back here. And then I'd wind up back here. And then back here. And then back here. And then back here. So you just want to have, you want to be done and do that.
alright, that's fine.
It's just as pointless as.
Profound, isn't it?
But that is
Which, you say number 1 with the 7th root of?
number 2.
Okay. So remember yesterday I showed you guys a couple of ways to find nth roots by, guess and check for, perfect cubes, perfect squares, and things like that. Well, other times it's always easier to prime factor. It is the tree. So if I divide this by 2, I get 320. If I divide that by 2, I get 160. I divide that by 2, I get 80. I divide that by 2, I get 40. I bet you if I divide that by 2, I get 20. Hey, guess what? If I divide that by 2, I get 10. Hey, if I divide that by 2, I get 5. How many 2's do we have? Let's count. 1 little, 2 little, 3 little 2's, 4 little, 5 little, 6 little 2's, 7. So, therefore, the 7th root of 640 is 2 7th root 5.
Wait, what?
Because this becomes,
There's already a C there. Oh, okay.
Oh.
Oh. Said it. I
you could have kept going, yeah.
Hey, can I do this?
Yes, ma'am.
Then you multiply 2 by
-6, 7.
This can come out, you get -6, 7th root of 5. The square root of 8 is what? It's 2 root 2.
That was a good guess.
What's 2 times 2? Very good. And then 45 becomes 3 root 5 because it's 9 and 5. Hey, is there anything I can combine here?
Yeah, we're gonna
done. This is a great trick. It's a great trick. Okay? And it works basically the same, I think, with as number 3 with the 486. If I look at 3, it has that 486 in it. If you go, you have a 2, and you have a 243, which is 3, and an 81, which is 9 and a 9, which is a 3, 3, 3, and a 3. Yes, ma'am. Where?
Oh, it's the 7th.
It's the 7th power. Yeah, I took all 7 of them out. Oh, what was the other question people were coming up with me already?
Oh, 31. I know that he just
What's the exponent of the first A?
the first
So they cancel out.
They cancel each other out.
Yeah.
So then all you get is b to the 3rd over b to the 4th. Everybody okay with a to the 1st times a to the negative 1st is just 1?
Yeah.
Everybody see that? Because if I send this guy down, it just becomes, it drops. Then I have power to power, so I have b to the 3rd over b to the 4th. That's the answer, because if I do, I have a fraction, I don't have any fractions in the denominator, do I? So I'm done.
Oh, I just saw the B to the 3rd. That's what I was doing.
Yes, ma'am.
On the quiz, will it be okay if we leave it in fraction exponent forms, or do you want us to
It'll if it starts in fraction, finish in fraction. If it starts in radical, finish in radical. Because that way you can switch it back and forth. You probably noticed that it's much easier to do all the math in fraction, but it's still, there is a time and a place that we want to know how to use nth roots, and that comes into play next week when we start solving equations with nth roots. It's easier when they're nth rooted as opposed to fraction rooted. What else do you want to look at? You're looking at this going, oh my God, I don't know what to do.
I really like 32. You should put that one on the test. You can change out the numbers except for that outside end.
You know, I've actually done this before, not in this class, but I've had one we did exponents, I think, in an Algebra 1 class. I did this.
Wow.
What kind of answers did you get?
Junk squared, I don't know,
1.
NA, 0. I mean, you'd be surprised.
I would just write no if I didn't know.
Yeah, the answer is no. Yes, sir.
Well, if junk is 0 though, then 0 to the power is still 0.
0 is the weird one, yes.
So this would be 1 or 0. Because
Unless we assume that all variables are not equal to 0. Yes, ma'am.
I've only been here for 2 days.
Oh, you should be fine. Joking, I know. We'll do it next week. We'll probably kick you out on Monday and so forth. Get caught up. I'm not. I mean, I'm a jerk, but I'm. You know, on the totem pole of jerkness, don't say anything. You're thinking about it already. You and Anna. I'm like here, like Solomon's here.
Solomon's related.
Are you serious?
Solomon.
Not a real.
What else do I look at?
Just like fake Solomon jerk.
Yeah, you can. How old were they though?
They're like from the
Yeah.
forensic stuff.
Yeah.
Do Twinkies
I
ever
get
really go bad
bullied all the
that
time.
fast?
What's 1 minus a fourth? Or what's 1 plus a fourth?
I'll Google how long does it take a Twinkie to expire.
They take forever.
I think the shelf life on them is around 10, 12 years.
That's so gross.
What's 1 plus a fourth?
You should see what Coca-Cola does to like metal. Put that in your body. What Kool-Aid does to almost
What's 1 plus a quarter?
Again, 1 days.
Write that as a fractional exponent. What is it?
It's not.
Tastes pretty good though.
What's 1 plus a quarter? All right, what is that as a fractional exponent? What is an improper fraction for 1 1/4? There's no such thing as a mixed number. What is it?
Try it.
You could have be so fucking sticky.
What else we got? What do you want to look at?
What? Do.
You what?
Steal my calculator without me even knowing.
You don't like meat?
Yes.
You don't think?
Someone else does it.
No. Because I eat cows.
I'll do it then. I know they do.
But I mean, I'm not.
Would I throw that 640 at you?
Can we use our
No, I'd probably go like the cubert of, was it 216 maybe? Is that one that works? I think that's about as big. I think so. Or no, it's 6. So I try not to go crazy on it because it's just not.
You're not too wrong.
What's up?
If we have the same calculator that you're gonna give us tomorrow, can we use our phones?
I usually just give everybody one.
Yeah, but yours aren't very good.
It's the same thing.
But mine's
Oh.
but it's the same thing.
Yes.
I'll do it.
Yeah, but remember when you do that, it's yeah. Oh, you want to make it. It's telling you to put it into a fractional exponent then, so it's just going to be k to the 3/5. Yes, sir.
How many questions are on the?
I think there's just like 8 or 9, maybe 10 of them, and they're varying degrees. Some of them will take you 2 seconds, some of them might take you 2 minutes.
Wait on the test.
I thought it was a
It's a lot of
quiz.
math.
Sorry, quiz. Yeah, it might take you 10 minutes for one. Not 10 minutes. I'm sorry. There's a couple that might. Hey guys, well, I told this the second hour, and I'm gonna. But same thing. It goes with you guys. I'm gonna take. The quiz is. I think it's only 10 questions. And I wrote, there's about 4 or 5 of them that shouldn't take more than a minute to do. And then there's 4 or 5 of them that might take 2 minutes. According to me, that's about 20 minutes long. Which means to you, that's probably about 30 minutes. Okay? At most. Seriously. So what I'll do is I'll take 10 minutes at the beginning, and we'll fly questions real fast in 10 minutes, and then I'll pass everything. Does that seem fair? Because it's not much to this. There really isn't. It's a lot of this stuff here. Maybe 2, maybe 6. It could be something to the 0. I don't know.
Are you gonna do it?
It might say b to the 0, 0. What's up?
Alright, I never like, what it changed when we were just talking about this. Okay.
Because then you have to raise the exponent and multiply through.
Oh, for real?
Alright.
Yeah.
You know, I was thinking about it, but like,
And then just apply from there.
Oh.
Ms. McMasters, you were saying something?
Technically,
You talk to me a lot today. This is weird. I'm not used to this.
according to hostess.
Hopworth, what's up?
But oh, I understand. I get it now.
Because you have x and x to the 4th.
Please excuse this interruption. The drill is now over.
Oh, that doesn't even happen.
Allow kids out of the classroom. Thank you.
When the bell rings in 3 minutes. What's the exponent of the first x?
We gotta go to the bathroom the whole time.
Is that the same thing?
No.
Okay.
Oh, yeah. See, people thought that was like the weak class. People like thought that was like yes, we got the first one.
Masters,
right.
what's up?
Let's go. I'm getting it. No, here.
Yeah, if you want to combine them all first before you flip them, that's fine. But what I would do though is I'd flip them, I put them all down in the denominator first and then add them all together. That way you can see what you can simplify. I always move my negatives first. Okay. Hey guys, make sure you get chairs for me, okay, today?